So here we are with Lecture 17, Section 3.8. So we are going to focus on the equations of lines and formulas for the equations of lines. So first off, how many different types of lines are there? Well, mathematicians will group them into three different types. We have the vertical line, the horizontal line, and the slanting line. So the vertical line, pretty much, if you think of anything that is vertical, that is what a vertical line is. So for example, if we have our coordinate axis, so our x values and our y values, a vertical line would be any that is going straight up and down. So now when we're trying to figure out what the equation for a vertical line is, let's look at an example. Let's say that this line right here was, let me zoom in on it. Let's say I was looking, backing up, there we go. Let's go in here, okay. So let's look at this point. I'm going to call this point, let's say, -3, 0. Okay, that's that point right there. If I was to ask you to tell me at least the x or the y value for each of these other 3 points, do you think you could tell me one of them? For example, could you tell me the x or the y value for this random point right here? Well, I don't know what the y value is. I really don't see a tick mark here, so I can't calculate anything there. But I can tell you I do know the x value, because the x value is going to be -3, even though I don't know what the y is. And then for this point here, can you find the x or the y? Well, once again, I have no idea what the y value is, but I do know for certainty that the x value is -3. Same for this point down here. I don't know what the y is, but I do know the x is -3. So maybe you're seeing the pattern here that regardless of what point I pick on this line, I don't know what the y value is, but I know for certainty that x is always going to be -3. So the equation for a vertical line is always going to be x equals k, where we have k, y. Okay, so whatever x value you have, that is going to be plopped in right here. Well, for the equation we had here on our example, the equation for this would be x equals -3. Why is this? Because the x values are always -3, regardless for what the y value is, excuse me. Okay, so let's go ahead and look at the horizontal lines. Well, horizontal line is, just think of like the horizon. It's that nice flat line, the flattest possible line. Let's go ahead and draw, oops, that looked ugly. Let's draw one in right here. All right, so once again, we're going to pause, or we're going to spend some time thinking about how we would find the equation of a horizontal line. So let's just say, for this example, that this point here is 0, 2. Once again, I'm going to ask you to go ahead and tell me either the x or the y value for this point. Pause the video and think about it. Can you find the x or the y value? Well, I can't find the x value because I don't know how many tick marks out to go here. But I do know the y value, which is 2, even though I don't know the x value. Once again, for this point here, I would not know what the x value is, but I do know the y value is going to be 2. So any point on this line, we may never know what the x value is, but we know for certainty that the y value is always going to be 2. So very similar to vertical lines. So the equation for this is going to be y equals h, where we have x, h. So h is a y value from that line, because the y values are always going to be whatever that point would be. So this one, try write down the equation for that line. Well, it's going to be y equals 2, because the y value will always be 2, regardless of what the x values are. All right, so let's take a look at the slanting line. So there are many different types of slanting lines. In fact, let me go ahead and draw 2 different graphs. So one thing to keep in mind is when we're reading graphs, we read from left to right, just like how you would read a book. So you read from left to right, left to right. So there are 2 sort of main different types of slanting lines. They're the ones that slant that have a positive rise. So as you read from left to right, it slowly rises upwards. So this would be a positive, this has a positive rate of change for this line. The other kind of slanting line we would have is downward slanting lines. Okay, notice all my lines have arrowheads. Those are important to include. All right, so the generic equation for this line, it's a little more difficult to explain than the other ones, so I'll just give it to you here. The main generic one to use would be y minus y sub 1 equals m times x minus x sub 1, where m is the slope of my line, and x sub 1, y sub 1 is a point from the line. Okay, and this one here is called, let me write this out here, this is called the point slope formula. How do I get that? Well, most of the time in math, things aren't that creative when they name things. If you're reading this out, remember the things that we input are the point and the slope. So if I read this from left to right, what's the first input I find? I find a point, and then I find a slope. And that's the name of this equation, point, slope. Hopefully that helps you memorize that. So for the writing an equation of a line, what are the steps that we need? Well, the first step we're going to do is to first write down or identify your given information. Identify the given information. And then from that information, the next step is to decide what kind of a line you have. Okay, is it slanted, horizontal, or vertical? Third step is to write down the formula you're going to use. And the third step, the last step, is to fill out the formula. Okay? And simplify if necessary. All right, so let's take a look at an example. All right, example 1. Write an equation of the line. Okay, so right there I know I'm going to be writing the equation of a line because it says write the equation of a line. Write the equation of a line that, what? It passes through the points -2, 5 and -1, -2, -1. All right, so my given information is it passes through these 2 points. So now I need to decide what type of a line it is. Well, let's go ahead and just graph this one and see what kind it might possibly be. So just a quick sketch. Let's see, -2, -5, or -2, +5. So -2, 1, 2, 3, 4, 5. So -2, 5. So it's going to be up there. -2, 5. And then disregard this point right there. So -2, 5, and -2, -1. So -2, -1 right there. Hey, you know what kind of line this is? This is a vertical line. Another way we could have noticed that before having to graph it was just notice the x values are the same. So it's a vertical line. All right, so we've decided the type of line it is. So now we're going to write down the formula we're going to use. So we're going to use x equals k. All right, so when you're showing your work for your exams, please make sure to write down the formula you're using. Because even if you don't necessarily input things correctly, if you show me you're using the right formula, you are going to get some points for that. Okay, so we're going to know we're going to use x equals k. And then the question is, what is the k value? Well, the k value is your x, which remember is going to be the same regardless of which point you choose. So k is going to be -2. Which means the equation of my line is, ooh, that was ugly. The equation of my line is x equals -2. Not too bad. All right, let's move on to the next one. So example 2. Write the equation of a line that passes through the points 4, 5, and 8, 5. Answer in slope-intercept form. All right, let's go ahead and just graph these because we need to figure out what type of a line it is. So we have 1, 2, 3, 4. Actually, wait, let me back up here. I need to fit 8 on here. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5. All right, let's plot these. First point is 4, 5. So 1, 2, 3, 4, and then up 5. 1, 2, 3, 4, 5. Second point is 8, 5. So 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5. Boop. And what do you know? The y values are the same, so this is a horizontal line. And instead of having to plot this out, we could have just looked here and saw, oh, y is the same. That must mean it's a horizontal line. So this is a horizontal line. So the next step, we need to write down our formula, which is, we're going to use y equals h. And what is the h value? Well, it's your y value, which is 5. So y equals 5 is the equation of our line. And so, question here, what is slope-intercept form? Well, slope-intercept form is, as you remember, y equals mx plus b, where our slope is m and our intercept is b. So remember, if you're reading this off, this is going to be slope, and then you read intercept. Okay, there we go. So, question is this in slope-intercept form? Does our line have a slope? Well, what's the slope for a flat line? Well, the slope for a flat line, that would be the smallest slope possible. In fact, does a flat line even have a slope? It doesn't. So the slope for a flat line would be 0. So if I was to write the equation for 0 in there, it'd be 0 times x, which means this would be gone. We'd just be left with our intercept value of b. So this actually is in slope-intercept form because y equals 0x plus 5 would simplify back into that form. However, some professors do like it if you write it out like this. I do not care if you write it in this form or this form. Either one would be acceptable to me. Either with the 0x or simplify down to that form. All right, so let's take a look at the special relationships between lines. Okay, so there are many different ways that two lines can cross one another, but there are two special, unique ones. So if two lines are parallel, their slopes are identical. If two lines are perpendicular, their slopes are opposite and reciprocals. Alright, so how would I describe opposite reciprocal? Well, if one of you had a slope that was -3 over 2, the opposite reciprocal would be, well, what's the opposite of a -3 over 2? That's a positive 3 over 2. Then what is the reciprocal of 3 over 2? You're just going to take the flip of that, which would be 2 over 3. So the opposite reciprocal of this number would be 2 over 3. Okay, let's go ahead and take a look at an example. Example 3. Write an equation of the line that passes through the point -2, 3 and is perpendicular to the line 2y plus 4x equals 5. Answer in slope-intercept form. All right, so I'm asked to write the equation of a line, and when I want to write the equation of a line, I want to know what kind of a line it is. But all I have here is one point and then another equation of another random line. And I know my line's perpendicular to it. So real quick, what does perpendicular mean? Well, perpendicular means that the two lines, when they cross each other, they form a right angle. Okay, so these two lines would be perpendicular because they form a right angle when they cross. Two lines would be parallel if they run directly alongside each other and never ever cross. Okay, so we're looking at a horizontal, we're looking at two perpendicular lines. So the first thing I want to do is try and figure out the slope of my line. Because if the slope of my line is 0, I know my line is going to be horizontal. We went over this earlier. So the question here is, what would the slope of a vertical line be? Well, remember, the slope of a horizontal line was the smallest number possible, so it is the flattest number possible. That means a vertical line, since it's the steepest slope in the world, the steepest slope must be the largest number there is in the world. What's the largest number in the world? It doesn't exist. The largest number does not exist. So the slope for a vertical line is actually undefined. Kind of interesting, but yep, that's the slope for a vertical line. And then the slope for a slanted line is any other number except for 0 or undefined. So what we're going to do is take a look at the slope for the given line and then try to see if we can figure out what the slope of our line is. And once we do that, we can decide what type of line what type of line ours is. So first, we're going to look at the slope of the other line. Okay, because that's going to help us figure out what kind of a slope our line has. So we have this line here, 2y plus 4x equals 5. I need to find the slope from this line. Well, to do that, I need to get this into slope-intercept form. So let's go ahead and do that. You can pause the video and try solve for y and check back in with me. So solving for y, let's do 4x. Okay. Then we have 2y equals negative 4x plus 5. And then getting y by itself, divide by 2, divide by 2, divide by 2. All right, let's see this simplified out. Y equals negative 2x plus 5 over 2. All right, so what's the slope of this line? The slope of this line is negative 2. Remember, this is not our line. This is the other line. This is the line that my slope is perpendicular to. So how do I find out what my slope is? Well, remember, my slope is perpendicular. So perpendicular lines, what do we know about perpendicular lines? Their slopes are opposite reciprocals. So to find my slope, I'm just going to take the opposite reciprocal of negative 2. My slope is going to be, okay, so the opposite of 2 is positive 2. And then the reciprocal of 2 is going to be 1 over 2. So then the equation, or the slope of my line is going to be positive half. So my slope is positive half. All right, so let's decide, is my line vertical, slanted, or horizontal? Well, looking at the slope, it's not 0, so I know it's not horizontal. And it's not undefined, so it's not vertical, which means my line is slanted. So my line is slanted. Therefore, we are going to use the equation y minus y1 equals m times x minus x1. All right, so let's continue on the other side here. So what do we need to fill this out? Well, to fill this out, I need my slope and 1 point. Do I have my slope? Yes, I do. I found it right here. It took a lot of effort to find this one. I want to use it. And then a point, well, I'm given this point right over here, -2, 3. So let's go ahead and plop these in. The point we're using is 3, -2, and then my slope is 1/2. All right, let's go ahead and plug these in. Okay, watch that negative there. There's the double negative. Let's go ahead and simplify that actually to get rid of that double negative. Okay, so normally we'd be perfectly fine just boxing this answer because that's an equation of a line. The problem is what we're directed to do at the end of this problem. Answer in slope-intercept form. This is not in slope-intercept form because remember, slope-intercept form has y by itself. So we need to go ahead and solve this for y. So let's go ahead and solve for y. You can pause the video and try to solve by yourself or follow along with me. Alright, so first thing I want to do is distribute in that half. Get rid of those parentheses. So then we have 1/2 x plus 2, and I'll put the 2 over 1, times that half. Which means those 2's simplify. They cancel each other out, and we're just left with 1 there. So we have y minus 3 equals 1/2 x plus 1. So let's go ahead and get y by itself, so we'll add the 3 to both sides. Then y equals 1/2 x plus 4. And there we go. We have it in slope-intercept form. We're done. Box our answer, and we are POW.